Okay, so today we're working on section 6.3, which is properties of trigonometric functions. So we have 4 or 5 properties we're going to go over in this section. Some of them you might have already thought about as you're working through the homework last night, but we'll just formally write them all down. So this first one is a little bit long, so I already wrote it down ahead of time. Our first property of trig functions is that a function is called periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus p, and f of theta plus p is equal to f of theta. The smallest value of p is called the period of f. Okay, so a function is called periodic. The important part here is that these outputs are the same. Okay, so every time we change our input by this number p, we get the same output. So periodic means that our values repeat. Okay, so periodic means our values repeat. Okay, so for sine and cosine, maybe you have thought about this already yesterday a little bit. But what we're going to do is we're going to figure out what the period of sine is, what the period of cosine is, and what the period of tangent is. So we'll work through those together to kind of logic through why the periods are what they are, and then I'll write it down formally for you. So one thing we know from section 6.1 and section 6.2 is when we draw an angle in standard position, even though our angles may be different, the terminal rays in that reference triangle and that reference angle start repeating at some point. So help me out with this one. 1 full revolution is equal to how many degrees? Go ahead and shout it out. 360. How about how many radians? How many radians in a full revolution? 2 pi. Okay, great. Okay, so what we know is that every time we have an angle, if we were to add 2 pi or 360 degrees to it, we would actually come back to our original angle, right? We just continue to go around every 360 degrees or every 2 pi. So what I mean by this is if, for example, we want to evaluate sine of pi over 3, and let's add 2 pi to it. So 2 pi plus 1/3 pi gives us 7/3 pi. So let's evaluate sine of pi over 3 and sine of 7 pi over 3 and see what they look like compared to each other. Okay, so to calculate sine of pi over 3, our first step is to draw our angle in standard position. Of course, we know pi over 3 is 60 degrees, so it looks something like this. In order to evaluate sine of pi over 3, we would drop a perpendicular to the x-axis, forming a triangle. We would then fill in our angles and our sides. And sine is opposite over hypotenuse, so we would get sine is square root 3 over 2. Now, let's look at how this compares to sine of 7 pi over 3. So again, I want you guys to think about this. This is trying to explain to you why the period is what I'm about to tell you it is. Okay, so 7 pi over 3. 7 pi over 3, this is 7 divided by 3 would be 2 1/3. So we're going to go 2 whole pi plus 1/3 more. So this blue angle is 7 pi over 3. And even though this angle is not the same as just regular pi over 3, the reference triangle and this reference angle is the same, right? We drop a perpendicular forming a triangle. This is still 60, this is still 30. The sides are still 1√3 and 2. Sine of 7 pi over 3 would be opposite over hypotenuse. So sine of 7 pi over 3 is, again, square root 3 over 2. Okay, so it turns out that for sine, anytime we make a full revolution, we get back to where we started, and we're going to have those outputs. This f of theta plus p is equal to f of theta. We're going to have these outputs. We're going to have repeating values. And you can think about this if we were to make 2 full revolutions and come back to this angle, sine would again be root 3 over 2. If we made 3 full revolutions and come back to this angle, we'd get the same output. So it turns out that for sine and also for cosine, they both have a period of 2 pi. And this should hopefully make sense to you from this perspective, right? Every time we go 2 pi, we come back to where we started, and our outputs are going to look the same. Okay, tangent's a little bit trickier, so let me write down our findings for sine and cosine, and then I'll explain to you why tangent is a little bit different. So the first thing we have is that sine is periodic with period 2 pi. So that means that sine of theta plus any multiple of 2 pi, so we write that as 2 pi times k, is equal to sine of theta for any integer k. Okay, cosine, for the same reasons, has a period of 2 pi as well. So cosine is periodic with period 2 pi, which means that cosine of theta plus 2 pi k, so however many full revolutions we add on there, is equal to cosine of theta for any integer k. And remember, integer just means whole numbers. So it can be a positive whole number or a negative whole number. Now tangent is a little more complicated. I'm going to tell you what the period of tangent is, and then I'm going to explain to you why it's different than sine and cosine. So tangent is periodic with period of just 1 pi. And I'll explain why the difference in just a second. So that means that tangent of theta plus pi k is equal to tangent of theta for any integer k. Okay, so it is true that for tangent, when we hit 2 pi, our outputs start repeating. But that definition of periodic said that the smallest value of p is called the period. So the smallest value. So why does tangent have period of 1 pi, but sine and cosine have period of 2 pi? It's true that they all start repeating output values at 2 pi, but tangent actually repeats it at 1 pi, at 2 pi, at 3 pi, at 4 pi, etc. So the easiest way to kind of see this difference is by looking at the positive and negative values. So remember from last lecture, my shortcut was all students take calculus. This tells us what is positive and negative in each quadrant. Okay, so let's take a look at sine. What I'm going to do is look at these 4 quadrants and look at the pattern for sine. So sine is positive, positive, negative, negative, positive, positive, negative, negative. So that pattern of the positive and negative outputs doesn't start repeating until 2 pi, right? Positive, positive, negative, negative, then we start over. Cosine is going to be positive, negative, negative, positive, positive, negative, negative, positive. So again, for cosine, that pattern of positive and negative outputs doesn't start repeating until 2 pi. Now tangent is positive, negative, positive, negative, positive, negative, positive, negative. So it actually turns out that tangent starts repeating that positive negative pattern at pi, and then again at 2 pi, and then again at 3 pi. And if we had these reference triangles, if we had 60 degrees in the first quadrant and 240 degrees in the third quadrant, we would have these matching triangles, and the output here would be the same as the output here. Okay, so tangent actually starts repeating values sooner than sine and cosine. Sine and cosine actually would repeat the same values. We'd have the same triangles, but they would be opposite sign. One would be positive, one would be negative. So the period doesn't start until 2 pi. Okay, so that was my big long explanation. So what do you guys need to know from this? You need to know that the period of sine and cosine is 2 pi, and you need to know that the period of tangent is 1 pi. Remember, we also had those reciprocal functions, cosecant, secant, and cotangent. Those have the same behavior as the original function. So cosecant and secant will have a period of 2 pi, just like sine and cosine. And then cotangent will have a period of 1 pi, just like tangent. So normally we focus on sine, cosine, and tangent, and then the reciprocal functions, they have a similar behavior. Okay, so how do we use these periodic properties? We can use these as a shortcut. We can use these to simplify values. You're welcome to use these. Usually they're not entirely necessary. So we'll just do 2 quick examples of how this might make your lives a little bit easier, how to simplify some things. Anybody need more time on this page? Okay. So let's find the value. And again, remember on your homework, you might see find the value, or you might see the word evaluate. Evaluate means find the value. Okay, so both of those mean give me the answer. So we'll just do 2 quick ones here. First one, let's find the value of sine of 17 pi over 4. Now there's 2 ways of doing this. The first step is, of course, to draw the angle in standard position. So if you wanted to, you could think about 17 pi over 4. You can convert to degrees, or you could leave it in radians here and figure out where that angle lies. This is a really large number, though. So what I'm going to do is I'm going to use the periodic properties, and I'm going to pull off multiples of 2 pi to simplify. So what we know is that every time we go around 2 pi, we come back to where we started. So what I want to do is think about doing the division here, right? 17 divided by 4, that's 4 1/4. So what I'm going to do is write this, oops, I want my sign first. I'm going to write this as sine of 17 divided by 4 is 4 1/4. So I'm going to write this as 4 pi plus 1/4 pi, so pi over 4. Now this part, 4 pi, this is 2 full revolutions. In other words, this is 2 pi times 2. So because sine is periodic with period 2 pi, this part actually doesn't matter, right? We make 2 full revolutions. We would get the same value as just sine of pi over 4. So essentially what you can do is you can subtract off multiples of 2 pi to make this problem easier. Okay, so now we're asked to find sine of pi over 4. That one should be really quick. Pi over 4 is 45. We know our sides are 1, 1, and root 2. Sine of pi over 4 would be 1 over root 2. Rationalizing this, we would get root 2 over 2. Okay, so we can use this periodic property as a shortcut to make this problem simpler for us. Any questions on that? Let's do one more really quickly. Next one, let's do cosine of 7 pi. Okay, so again, cosine is periodic. Help me out with this one. What's the period of cosine? Shout it out. 2 pi? Okay, so what I want to do is I want to rewrite this as some multiple of 2 pi plus something else. And then the multiples of 2 pi I can pull out. So 7 pi, I can write it as 6 pi plus 1 pi. And it doesn't matter which order we put this in. This 6 pi is 3 full revolutions. In other words, this is 2 pi times 3. And since cosine is periodic with period 2 pi, we can kind of pull out any multiples of 2 pi. So that means this is just equal to cosine of pi. All right, so let's evaluate cosine of pi. When we're doing our quadrantal angles, remember we had those shrinking triangles from last class to evaluate the quadrantal angles. And our shortcut to remember those shrinking triangles was to, okay, so first step, draw our angle in standard position. Here's pi. Now what we want to do with a shortcut, and so we don't have to think about those triangles all the time, is to look at the point that's at a distance of 1 away from the origin. The x coordinate of this point is -1. The y coordinate of this point is 0. Okay, these go in alphabetical order, cosine, sine. So what should our answer be here? Cosine of pi is equal to what? -1, good. Okay, so again, this is just a shortcut you're welcome to use. If you don't want to use a shortcut, the other way you could do this is by drawing out this angle, 7 pi, right? You'd go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and you'd get right back here. Okay, so these periodic properties just help you simplify things a little bit to make the numbers smaller and easier to work with. Do you necessarily have to use them? Maybe, maybe not. But if you have a really large angle, it just makes things simpler. Any questions on either of those two examples? Okay. Our next property we already talked about last class, but it was listed in this section separately, so I'll include it here again. And this is the positive and negative properties. So what trig function is positive and negative in which quadrant? The easiest way to remember this is by all students take calculus. So all students take calculus as you're going through from quadrant 1 to 4. This tells us what is positive in that quadrant. So in quadrant 1, we have an A, that means all sine, cosine, and tangent, all three are positive. In quadrant 2, we have an S, that means sine is positive, which means cosine and tangent are negative. Here we have a T, that means tangent is positive, which means sine and cosine are negative. Here we have a C, which means cosine is positive, which means that sine and tangent are negative. The reciprocal trig functions, cosecant, secant, and cotangent, have the same positive or negative value as the original function. So the cool thing about this, and you'll see these problems on your homework and on your quiz, and you'll use something like this on your exam next week, is that if we know a little bit of information about an angle, we can actually determine what quadrant the angle is going to be. So let's figure out what quadrant is theta in. So we'll do 3 of these, A, B, and C. First one, I have that cosine is negative and sine is negative. Don't shout it out yet. I want you to think about this for a second and figure out these 2 pieces of information will uniquely determine what quadrant the angle is in. Okay, so we're going to use this later on in the class quite a bit when we're solving equations. All right, so if cosine is negative and sine is negative, remember these are labeled quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If cosine and sine are both negative, what quadrant is theta in? Go ahead and shout it out. 1, 2, 3, or 4? 3. Awesome. Okay, so this is the only quadrant where both of those are negative. Let's do 2 more really quickly. How about where is sine positive and cotangent is negative? So take a second to think about that. Now remember, cotangent is a reciprocal function, so you have to think about the letters for tangent. All right, what do you guys think? Where is sine positive and cotangent negative? What quadrant? 2, good. Okay, let's do one more. How about where is cosecant positive and cosine positive? Take a second to think about this one. What do you guys think? What quadrant is theta in? 1, yeah. So anytime we have two different trig functions that are both positive, has to be in quadrant 1. Right here, we only have one letter in these three quadrants. So here only sine is positive, here only tangent's positive, here only cosine's positive. So here we'd have sine and cosine are both positive. We have to be in quadrant 1. Okay, so we can use these positive negative properties to determine what quadrant an angle is in. Any questions on this? Anybody need more time on this page? All right. Next set of properties. Again, this is something we already saw in the last section, but I'll list them here for you as well, just so you have them all in one place in your notes. The next one is called the reciprocal identities. And we have that cosecant of theta is the reciprocal of, here, let me write these out and then you guys can help me fill these in. Okay, so help me fill these in. Cosecant is the reciprocal of what? Sine, cosine, or tangent? Sine, good. Secant's the reciprocal of what? Sine, cosine, or tangent? Cosine. And cotangent's the reciprocal of tangent. These identities work in both directions. So sine is also the reciprocal of cosecant. Cosine is, of course, the reciprocal of secant. And tangent is, of course, the reciprocal of cotangent. Okay, so we talked about those last class, but here we'll list them again just so we have all the properties in our notes in one place. But you should recognize that we can use these identities to go from cosecant to sine or from sine to cosecant. So we can kind of use them in both directions. The next identity we haven't seen yet, and this is one of the most useful ones. There are two in this section that will be, I'm going to go ahead and tell you through calculus and through physics. We have two identities that are the most used out of everything we'll do this semester. And the two are quotient identities, which we'll do right now. And then the next one we'll do is Pythagorean identities. So the next two properties we're doing are the most used formulas from this class, the most used you'll see in your other class. So the first one is called, and I'll put them in a big blue highlighted box for you guys. So the next one is called the quotient identity. So remember, quotient refers to a fraction. So what we want to do is take a look at what happens if we form this quotient of sine over cosine. Okay, so sine, we think SOHCAHTOA. So sine is opposite over hypotenuse. SOHCAHTOA tells us cosine is adjacent over hypotenuse. I'll do this division the long way. Remember, when we have division by fractions, we start by writing the numerator, switch to multiplication, and we multiply by the reciprocal of the denominator. Okay, now we have hypotenuse in the numerator and denominator. That cancels out. So we get opposite over adjacent. All right, so what did we end up with? Opposite over adjacent is equal to what? Tangent. Okay, so what did we just figure out? We just figured out that sine of theta over cosine of theta is equal to tangent of theta. This is one of the most used trigonometric identities out of this entire semester. Okay, so this one's really important. This one is not on your formula sheet. You need to memorize this. Tangent is equal to sine over cosine. All right. So that was a quotient identity. Now let's do a problem where we use this quotient identity and some of the other identities we've seen to solve a problem. So find the values of the other 4 trig functions. Given that sine of theta is equal to -5/13 and cosine of theta is equal to 12/13. Okay, so there's 2 ways we can solve these problems. And as we're going through this next chapter, usually there's 2 kind of approaches for most of these problems. The first one is algebraically. Algebraically meaning we use formulas. The second way is graphically, meaning we use pictures. I would encourage you on the homework to try it both algebraically and graphically and make sure that both methods that your answers match. I'll show you both when time allows. And on a quiz or a test, you're welcome to use whatever method you prefer. I find that students usually like one or the other better. Makes no difference to me. First, let's do the algebraic method. So algebraic meaning using formulas. So we're asked to find the other 4 trig functions. So we have sine and cosine. Let's find tangent. So we just figured out in the quotient identity section that tangent is equal to what over what? Sine over cosine. Okay, so tangent's equal to sine of theta over cosine theta. So we have sine of theta, which is -5/13. Oops, let me do this over here, over cosine of theta, which is 12/13. You can do this division however you'd like. The easiest way is to recognize that these both have a common factor of 1/13. So those actually will cancel out and we just get -5/12. The other way of doing this is by writing the numerator, switching to multiplication and multiplying by the reciprocal. All right, so we're asked to find the other 4 trig functions. We found tangent. Let's find cosecant. Cosecant is the reciprocal of sine. So here we're given that sine is -5/13. That means that cosecant is -13/5. Secant. Secant is the reciprocal of cosine. So we know cosine is 12/13. That means that secant is 13/12. The last one is cotangent. Cotangent's the reciprocal of tangent. So tangent was -5/12, so that means that cotangent is -12/5. Okay, so that was the algebraic method. The other way we could do this is graphically. Graphically meaning drawing a picture. So let's draw a picture of our angle theta. And then once we have that picture up, we can use that picture to find these other values. So the first thing we need to determine is what quadrant theta is in. We have that sine is negative and cosine is positive. So if sine is negative and cosine is positive, what quadrant is our angle in? 4, good. Okay, so the first thing we need to do is draw our angle in quadrant 4. Now we're told that sine is -5/13. So opposite would be -5, hypotenuse would be 13. We're told that cosine is 12/13, so adjacent is 12, hypotenuse is 13. Now that we have this picture, we could find the values of the other 4 trig functions using this picture, using the graphical method. So tangent would be opposite over adjacent, so -5/12. Cosecant is a reciprocal of sine, so that would be hypotenuse over opposite. Here's hypotenuse over adjacent, etc. Okay, so you're welcome to use either the algebraic method or the graphical method. The one challenge of using the graphical method is you'll still need to ask yourself, should your final answer be positive or negative? or if you track this negative sign through, then you'll get the right answer. When we're using these formulas, those already account for that and will give you the correct positive or negative answer. Any questions on this problem? Okay, so as I mentioned earlier, the quotient identity, that's one of our 2 most used identities. The next most used identity is called the Pythagorean identity. Okay, so what I'm going to do is take a look at a generic triangle. Here's a generic triangle. The side across from our reference angle is called the opposite. The side next to it is called the adjacent. And of course, the side across from our 90-degree angle is called the hypotenuse. So what we're going to do is we're going to start with the Pythagorean theorem. And we're going to rearrange the Pythagorean theorem into something that relates our trig expression, so sine, cosine, and tangent. All right, so the Pythagorean theorem says a squared plus b squared is equal to c squared. Remember, a and b are the legs and c is the hypotenuse. Okay, so I'm going to write this as opposite squared plus adjacent squared is equal to the hypotenuse squared. Right, that's just the Pythagorean theorem. A squared plus b squared is equal to c squared. Okay, so now our goal is to put this in terms of sine, cosine, or tangent, to put it in terms of some trig expression. So our trick here, I'm going to divide both sides of the equation by hypotenuse squared, which is just some number, right? So we're allowed to do that. The next thing I'm going to do is pull out these squares, and I'm going to rewrite this as opposite over hypotenuse squared. And what should I write on that right side of the equation? Hypotenuse squared over hypotenuse squared is equal to what? What's say 5 over 5 or 10 over 10 or 13 over 13? 1. Okay. All right, so now our goal is still to get this in terms of sine, cosine, and tangent. Once we get to the final step, I'll put it in a box for you. So we notice we have opposite over hypotenuse. Opposite over hypotenuse is equal to what? Sine, cosine, or tangent? Sine, okay, so we have sine of theta squared plus, now I have adjacent over hypotenuse. What's that equal to? Cosine? All right, so the way we normally write this is if we have sine of theta squared, we like to write this, our normal notation is sine squared of theta plus cosine squared of theta is equal to 1. This is the Pythagorean identity. This, along with that quotient identity, is one of the most used trig expressions. So when you're in calculus or physics, you might use this. This is really a really neat formula. So what this says is for every angle theta, it doesn't matter if our angle is 30 degrees or 45 degrees or 90 degrees or negative 270 degrees, for every single angle theta, it is always true that sine squared of theta plus cosine squared of theta will always, always, always be equal to 1 for every single angle theta. Now, the real benefit of this is that if you know sine or cosine, you can plug it into this formula and figure out what the other one is. Okay, so this is a really nice formula that relates sine and cosine to each other. There are 2 other versions of the Pythagorean identity. I'll write them down for you, but I'm not going to put them in a box because I don't think you should memorize them. But what you should recognize if you need them later on is that there are other versions. So if we take this equation and we divide both sides through by sine squared of theta, we'd have sine squared theta over sine squared theta, that's going to be 1. Cosine squared over sine squared would be cotangent squared. And then 1 over sine squared would be cosecant squared. If we take this equation and divide both sides through by cosine squared, we would end up with tangent squared of theta plus 1 is equal to secant squared of theta. For our class, we're not going to use these two other versions. You absolutely don't need to memorize them. But what you should recognize is as you move on in your math classes, should you see some trig expression squared, and a 1 in the equation, you should just recognize like, aha, that looks like some other version of my Pythagorean identity. This one we'll use a bunch, okay? So far from this section, what you should memorize is that tangent is equal to sine over cosine, and then sine squared plus cosine squared is equal to 1. Those are the two that you absolutely need to memorize. These are just other versions of this. Any questions? Okay, so let's do some problems where we use all of these properties now. So first one, find the value. Let's find the value of tangent of 25 degrees minus sine of 25 degrees over cosine of 25 degrees. Okay, so when you take a look at this problem, your first thought might be like, oh, let's find the value of tangent of 25. Let's find the value of sine of 25. Let's find the value of cosine 25. If you were to draw out 25 degrees really quickly, you'd realize that that triangle is not one of the two that we know how to do by hand. So then what you should think is, how else can I solve this problem? Okay, so what we recognize over here is we have sine over cosine. Sine over cosine is equal to what? Tangent, okay? When we have these angles match, this is equal to tangent of whatever this angle is. Okay, so these angles have to match. So sine of 25 over cosine of 25 is equal to tangent of 25. And we won't have anything in this class where it's too tricky and you'll see things that don't match. So we have tangent of 25 degrees minus sine of 25 over cosine of 25 is tangent of 25. So tangent of 25 minus tangent of 25 is equal to 0, yeah. And you'll see this on your homework. They give you these kind of complicated looking problems, but they should work out somewhat nicely. Let's do a couple more. How about sine squared of pi over 8? Plus 1 over secant squared of pi over 8. So again, your first thought might be to actually evaluate these. Sine squared of pi over 8. Once you draw that angle in, you'll realize that's not one we know how to do by hand. So the next thing you should do is take a look at this. Whenever we have a sine squared or a cosine squared, you should think, that's probably going to be Pythagorean identity. So the first thing we'll do is we'll rewrite this 1 over secant squared of pi over 8. Using the reciprocal identity, we know that the reciprocal of secant is cosine. So this is just cosine squared of pi over 8. Sine squared of any angle plus cosine squared of any angle is always equal to what? 1. Okay, so it doesn't matter what angle is inside as long as these match. Sine squared plus cosine squared is always equal to 1. And again, you won't see trick problems in our class where these angles don't match. Let's do one more. How about 4 times sine of 22 degrees times cosecant of 22 degrees? So again, your first thought might be to actually try and evaluate sine of 22, and you'll see really quickly that's not a triangle we know how to do. So we have some identities, we've learned some properties in this section that we can use to simplify things. So cosecant is the reciprocal of sine. So the first thing I'm going to do is rewrite cosecant as 1 over sine of 22. Now remember, sine of 22, this is just some number. So this and this cancel out. Those are just some number, and we just get 4. So as you're doing these problems on your homework, you'll see that these things should cancel out nicely. Any questions on this? Okay, let's do one more example for this section. And I'm sorry, we have one more property after this next example. Next example. Given that sine of theta is 1/3 and cosine of theta is less than 0, find the values of the other trig functions. Okay, so again, there are two ways of solving this problem. We can solve this algebraically meaning using formulas, or we can solve this graphically, meaning drawing the picture. I'm going to do it algebraically first, and then we'll do it graphically. I'll draw the picture, and we'll make sure that our answers match. On your homework or a quiz or a test, you're welcome to use whatever method you like the best. Okay. So here's what we know. We know sine, and we know cosine is negative. We're asked to find the values of the other trig function. So given that we know sine, the next thing we should work on is finding cosine. So we ask ourselves, what equation do we have that relates sine and cosine? So that's the Pythagorean identity. We know that sine squared of theta plus cosine squared of theta is equal to 1. Okay, the problem tells us that sine is 1/3. So that means that 1/3 squared plus cosine squared is equal to 1. Okay, next up, let's square this fraction. So 1/3 squared is 1/9. Next step, I want to solve for cosine of theta. So I'm going to subtract 1/9 from both sides. So if I subtract 1/9 from both sides, 1 is 9/9. So 9/9 minus 1/9 gives me 8/9. We're trying to solve for cosine of theta, so I need to get rid of this square. So the next thing I'm going to do is take the square root of both sides. Here my square and my square root cancel out, so I have cosine of theta is equal to, now anytime we take a square root of both sides of the equation, what do we normally write right here? Plus or minus. Now we're figuring out cosine of theta is going to be either plus or minus square root of 8/9. It cannot be both. It cannot be both positive and negative 8/9. So let's go back to our problem up here. This problem said cosine was less than 0. So because they told us cosine was less than 0, that means we're going to use the negative sign only. If they don't tell us cosine is positive or negative, what we have to do is look at what quadrant the angle is in, and based on what quadrant the angle is in, figure out if cosine is positive or negative. Okay. Next up, I have square root of 8/9. We need to simplify this as much as possible. So we can simplify a square root over the numerator and denominator, meaning that I can write this as square root 8 over square root of 9. Square root of 9 is, of course, 3. We need to simplify square root 8. You have to, on every homework, every quiz, every test, simplify your square root if possible. So what we want to do is pull out the perfect squares. So 8 is 4 times 2. So square root of 4 is 2. So this becomes 2 root 2. Okay, so our final answer here is that cosine of theta is negative 2 root 2 over 3. Any questions on that? Okay, so we have sine, we have cosine. The next step is to find tangent. What's our formula for tangent of theta? Tangent is equal to what over what? Shout it out. Sine over cosine. Sine of theta over cosine of theta. Okay, so sine of theta is 1/3. Cosine of theta is -2√2 over 3. Now we just need to simplify this. So the first thing we notice is the numerator and denominator both have a common factor of 1/3. So we can cancel those out. So we get -1 over 2√2. Remember, as we talked about last class, once we get our answer, we need to do 3 things. We need to figure out if our answer should be positive or negative. These formulas will account for that already. We need to rationalize our denominators and reduce our fraction. So to rationalize this denominator, I'll multiply by √2 over √2. That gives me -√2 over 2 times 2, I'm sorry, √2 times √2 is 2. 2 times 2 is 4. So our answer is -√2 over 4. Be very careful here. I see this mistake all the time. You are not allowed to reduce something that's under a square root with something that's not under a square root. So this is not equal to square root of 1 over 2. Okay, so you cannot reduce this 2 and this 4. Any questions on this? For the sake of time here, because I want to start working on the other section today, we still have one more property from this section. Cosecant, secant, and cotangent, to find those values, take the reciprocals, make sure you rationalize, and make sure you reduce your fractions. Let's look at the graphical method really quickly. If we wanted to solve this with a picture instead of with the equations, we know that sine is positive and cosine is negative. So the first thing we would need to do is determine what quadrant theta is in. So if sine is positive and cosine is negative, that puts our angle in quadrant 2. Drop a perpendicular, forming a triangle. This problem tells us that sine is 1/3. So sine is opposite over hypotenuse. The next step would be to find the third side of the triangle using the Pythagorean theorem. So a squared plus b squared is equal to c squared. Solving that, we'd get that our third side is 2√2. Now to fill in all of these other values, cosine is adjacent over hypotenuse, so that's 2√2 over 3, which is what we got right here, and cosine in the second quadrant is negative. Tangent is opposite over adjacent, which is what we had right here, 1 over 2√2, and then we rationalized. Okay, so you're welcome to do the algebraic method and use the equations, or you're welcome to draw a picture. The one thing you need to remember when you're drawing a picture is you need to remember to ask yourself, should your final answer be positive or negative? Using that, all students take calculus, or if you want, you can track through the positive and negative x and y values. Any questions on this? Okay, we have one more property from this section, and this is even and odd properties, which we learned in Math 126. Anybody need more time on this page? All right, so if you think about your Math 126 class, I believe this was section, I want to say 2.3 or 2.4 in Math 126, we had properties of functions. And one of these properties of functions we saw in Math 126 was classifying this function as even or odd. And then of course a function can be neither even nor odd. But a function is said to be even. I'm writing the abbreviated definition here. If f of negative theta is equal to f of theta, a function is said to be odd if f of negative theta is equal to negative f of theta, or we could put the negative on the other side of the equation. Okay, so these were our definitions from 126. I'm doing the abbreviated version here. In 126, our official definition was a function is said to be even if anytime x is in the domain, negative x is also in the domain, and f of negative x is equal to f of x. Okay, here our input for trigonometric functions is theta instead of x. They're just dummy variables. We can change out an x for theta, and it means the same thing. Okay, a function is said to be odd if when we plug in theta and negative theta, we get opposite values. Okay, so what I want to do is, again, I want you guys to think through this. Instead of me just telling you whether sine, cosine, and tangent are even or odd, I want us to explore this together and to figure out together which of the trig functions are even and which are odd. So what we need to do is we need to compare sine of theta to sine of negative theta and see if we get the same value or the opposite sign. We will compare cosine of theta to cosine of negative theta and see what happens. Do we get the same value or opposite sign value? Then we'll do it for tangent. And we'll come up if they're even or odd. Now remember the reciprocal function, secant, cosecant, and cotangent, they have the same behavior as the original function. So that means if sine is even or odd, then also cosecant would be the same. All right, so let's figure this out together. We want to compare sine of theta with sine of negative theta. So what I'm going to do is draw a generic theta and a generic negative theta. So here's a generic theta. If you want to think about this as 45 degrees or 60 degrees, whatever, it's just some generic angle. Now what I want to do is draw the same angle, but negative. So if this is theta, here is negative theta. Now I want you to realize if I had put this in quadrant 2, we would have the same output. So for example, if I put theta in quadrant 2, negative theta would look something like this. And I could do this for theta in any quadrant and come up with an equivalent negative theta. Okay, so let's just look at this picture here. I just want you to see, you can ignore this for now, but you can see that we could put theta in any quadrant and the same thing would apply. Okay, so let's look at our picture. Without actually knowing what theta is, we know that if we found sine of this angle and sine of this angle, the number portion should be the same because these angles match. So the triangles will match. What we want to figure out is in order to be even or odd, let me scroll back up here. If a function is even, we get exactly the same thing back. If a function is odd, we get the same thing back, but opposite sign. So one is going to be positive and one is going to be negative. So we already know we're going to get the same number back because these angles are the same. So what I want you guys to tell me, sine in the first quadrant. Sine in the first quadrant is what? Positive or negative? Positive. How about in the fourth quadrant? Sine in the fourth quadrant is what? Positive or negative? Okay, negative. So we get a positive one, positive sign back, and a negative sign back. So one is positive and one is negative. That means sine is what? Even or odd? Odd, right? They're of opposite sign. So that means that sine is odd. Now, if we had looked at these angles in the second and third quadrant, here we would get positive, here we would get negative, so those are also opposite. If we put them in any of the other quadrants, same thing would happen. Okay, so let's figure this out for cosine now. So everyone help me out with this one. Let's look at positive theta. So cosine in the first quadrant is what? Positive or negative? Positive. How about cosine in the fourth quadrant down here? Positive or negative? So we got positive, positive, so those match. So cosine is what? Even or odd? Even. Good. We get exactly the same thing back. If we had looked at these angles, we would have negative, negative, so those are exactly the same thing, so that would make it even. Tangent, using the same logic, is also odd. Right? We'd get positive, negative, or negative, positive. Okay, so sine and tangent are odd, Cosine is even. You should know this. So let's do a problem using these even and odd properties and see how we might apply them algebraically. And then we'll talk about graphically in the next section how these even odd properties apply. Okay, so now we have one problem that's going to use like three things we did in this section all together. So I have sine of negative 40 degrees over cosine of 400 plus tangent of 220. Okay, we want to evaluate this, find the value. So your first thought might be to draw out these angles, and you'll realize really quickly we don't know how to do any of these by hand. Okay, so what we recognize is we have sine over cosine. So we know sine over cosine is equal to tangent, but in order for that to work, these two angles have to match. Okay, so what I'm going to do is use the properties we learned in this section, and I'm going to rewrite both of these angles so that they are the same value. All right, so first up, we have sine of negative 40. We just figured out in the last section here that sine is odd. That means that sine of negative 40 is equal to negative sine of positive 40, right? 40 and negative 40 have opposite signs. So this is just using our odd property. In the denominator, I have cosine of 400. Now my goal is to get this angle to be the same. We know that cosine is periodic. Cosine and sine are both periodic with period of what? 2 pi or 360. So we can subtract off multiples of 360 or 2 pi here. So 400 minus 360 would give us 40. So cosine of 400 is equivalent to cosine of 40 using that periodic property. All right, how about tangent? Now, in order to simplify this problem all the way, it would be helpful if all of these angles matched. How about tangent? What's the period of tangent? Pi or 180. So we can subtract off multiples of 180. So 220 minus 180 gives us 40. And this should work out nicely on your homework, that all of these angles end up being the same. All right, we have one more step here. Negative sine over cosine. Sine over cosine is tangent, so now we have negative tangent of 40 plus tangent of 40. This is equal to what? 0, yeah.